Okay, dear students, so let's start today's work. तो हम एनालिटिकल मैकेनिक्स की बुक पढ़ रहे हैं हम और उसमें आज का हमारा टॉपिक है मोशन ऑफ एन ऑब्जेक्ट अंडर द इफेक्ट ऑफ सेंट्रल फोर्स। ठीक है, कंटिन्यू करते हैं फिर। तो क्या करेंगे इसमें हम सबसे पहले देखते हैं कि सेंट्रल फोर्सेस होती क्या है एंड व्हाट आर देयर प्रॉपर्टीज। Okay, so there are basically four types of forces, or we can say interactions, which are operative in nature, which are working in nature. Okay, so first one is gravitational force. As we already know that Newton's law of gravitation says G m1 m2 by r square. This introduces the force of gravitation. ठीक है, this capital G is a universal constant. These m1 and m2 are two masses which are applying gravitational pull on each other. Okay, r is the distance between them. Between them means center of one mass, and this is the center of second mass m2. So when we say r is the distance between them, it basically represents the distance between their centers, a straight line joining their centers. Okay, similarly we have read about electromagnetic forces where the electric component is given by Coulomb's law. It's k q1 q2 by r square. It is similar to the previous one. Okay, this is written in terms of charges. इसमें भी वही है, same, that if we take one charge q1 and another charge q2, these are not the point charges here, then r is the distance between their centers. R, this vector, is a line joining their centers. तो ये भी हमने पढ़ा हुआ है। ऐसे ही there are other forces, new weak forces, ये होती हैं, these are working inside the nucleus, and these are basically interaction of leptons, इलेक्ट्रॉन्स जैसे लाइट वेट पार्टिकल्स जो होते हैं उन्हें बोलते हैं। तो इलेक्ट्रॉन्स में हमने ये वीक फोर्सेस पढ़ी हैं, और स्ट्रॉन्ग फोर्सेस होती हैं बिटवीन, दीज आर आल्सो द न्यूक्लियर फोर्सेस व्हिच एक्ट्स बिटवीन द mesons and baryons. Baryons are the heavy weight particles, and mesons are the middle weight particles. So these two are the nuclear forces. और कैसी होती है नेचर में? शॉर्ट रेंज होती हैं, शॉर्ट रेंज। ओके, बट व्हाट अबाउट अदर टू? these two are central in nature, and these are long range forces. Okay, central in nature means the force interacts towards the center of the body. Okay, and the force of interaction, and it also depends upon the central distance from the center. ठीक, आगे कुछ प्रॉपर्टीज देख लेते हैं। प्रॉपर्टीज क्या होती हैं? इन दिस particular topic, in this particular chapter, we are only dealing with the central forces, means forces of these two kinds. Okay, and what about other these two forces? We will discuss this thing. I'll elaborately take a tutorial on this part in the classes of nuclear physics. Okay, जब वो सब्जेक्ट करवाऊंगा तो उसमें हम ये कवर कर लेंगे। फिलहाल के लिए हमारा टारगेट जो है वो सिर्फ सेंट्रल फोर्सेस है, और ये क्या करती हैं? दीज फोर्सेस फॉलो इनवर्स स्क्वायर लॉ। ठीक है, सो these forces are inversely proportional to square of the distance between them. This is due to geometrical dilution. Okay, let's understand some of their properties. So the first point is the central forces are conservative in nature. Conservative means, what do you mean by conservative? Conservative forces are those forces, actually the work done by these forces is independent of the path, independent of the path followed. Okay, you have read it in lower classes, +1 में भी पढ़ चुके हो आप। +1 में क्या पढ़ा आपने? एक आर्टिकल था बड़ा सिंपल सा, अच्छा आर्टिकल था, उसमें आप क्या लेते हो? ए पॉइंट लेते हो, बी पॉइंट लेते हो, ओके, और सीधा ऊपर जाते हो फ्रॉम ए टू बी। कितनी हाइट? h हाइट पे। सो द ग्रेविटेशनल पोटेंशियल एनर्जी from A to B was equal to mgh. This is equal to mgh. Now if we take another case in which this is point A, this is point B, okay, but we are not moving directly, but we are going in this way. Okay, इस तरह से गए ऊपर, तो हाइट कितनी ट्रेवल की? हाइट तो सेम ही ट्रेवल हुई, डिस्टेंस ज्यादा हुई लेकिन डिस्प्लेसमेंट तो यही हाइट है। इस बार फिर से व्हाट विल बी द पोटेंशियल एनर्जी वैल्यू? इट विल बी mgh. ओके, सिमिलरली यू हैव रेड इट इन दिस वे दैट इफ दिस इज a particle and this is b particle, so whether we go in this way or we go here from A to B directly in this way, or we go in this way, the gravitational potential energy in going from point A to B is mgh in each and every case. So it is independent of the path followed, independent of the path followed. But let us take an example of non-conservative forces. What are non-conservative forces? Work done by these kind of forces depends upon the path. For instance, we can take frictional force. Frictional forces. Frictional forces में क्या होगा? Whether you are going through a smooth surface or a rough surface, work done will vary according to the surface on which you are moving. ठीक है, एक में फ्रिक्शनल फोर्सेस ज्यादा लगेंगी, एक में कम लगेंगी, तो वो इस तरह की जो फोर्सेस होती हैं उन्हें हम बोलते हैं नॉन कंजर्वेटिव। बट the point is the central forces are conservative in nature, okay, as we have already done for gravitational force, which is conservative in nature. Second point here we need to understand is the forces can be written as the negative gradient of the potential energy, that is F is equal to minus of gradient of or derivative of this U with respect to R can be written in this form, where U is the potential energy of the system. ठीक हो गया? ओके, इजी है। नेक्स्ट पॉइंट देखते हैं। नेक्स्ट पॉइंट क्या होगा? उससे पहले कुछ let me erase this part. Okay, so what is the next point? Next point is the angular momentum remain conserved. In case of central forces, angular momentum remain conserved. Why is it so? How can you prove this? It is simple, because the central forces are directly proportional to r vector. Okay, r vector or r cap we can say. Magnitude wise छोड़ देते हैं, but directionally these forces are dependent upon this direction. These forces work in this direction. Okay, and what is the torque? Formula for torque is given by R cross F. How do we calculate torque? By this, using this formula. And what will be its value? R cross, let's say I am taking this force equal to some K multiplied with this. Okay, so this will be some K with this direction, and product of these two, R cross, let me write the vector first, cross R cap, this is 0, and if this is 0, what we can predict? We can say the torque is 0, which can be written as dl upon dt. dl upon dt is 0, implies L is conserved, L is constant. What is L? L is angular momentum. This is, you can also directly depicts it from Newton's law of gravitational motion, from Newton's law of rotational motion. लीनियर मोशन में क्या होता है? लीनियर मोशन में when force is zero, linear momentum remain conserved. In case of rotational motion, when torque is zero, angular momentum remains conserved. Okay, this was the third property, that angular momentum remains conserved in case of central forces. Last, fourth, one more property directly related to this one is that motion of the body is confined to a plane in case of central forces. Why is it so? Because L, we have proved it to be a constant. It's a conserved quantity, L, which is actually equal to R cross P. Okay, now if this is a constant, and what does this product represent? This represents that L is always perpendicular to R and P. L is always perpendicular to R and P. So if, let us assume, L initially is acting along z-axis. This is the direction of L. Okay, this is the direction of L. So what we are left out with, R cross P, R and P should be in xy plane. Otherwise, if let us say R comes out of the xy plane, then its direction, which is perpendicular to L, which is perpendicular to R, will not lie along the z-axis, but will lie along certain axis, which is other than z-axis, okay, which is inclined to z-axis at certain angle. तो अगर आपको L हमेशा कांस्टेंट फिक्स डायरेक्शन में रखनी है, फिक्स डायरेक्शन z में रखना है, तो आपको R क्या करना पड़ेगा और P क्या करना पड़ेगा? You will have to confine it within xy plane. Confine it within xy plane. ठीक है, you will have to do this. अगर आपको L की z axis में डायरेक्शन फिक्स रखनी है. So these are the few properties which we are going to use in this article. Next, one more important thing we need to discuss it first. That look, since we have already talked about that gravitational force here, it is a function of R. Okay, R. F depends upon R in this way, at least. It acts along this. Moreover, we are also discussing, we have also seen that motion is confined to a plane. Plane का मतलब two-dimensional motion है, third dimension नहीं आएगा. That's why what we will do, we will use a plane polar coordinates only to solve the problem. To solve this problem, we will use plane polar coordinates, only plane polar coordinates. Why is it so? Why are we choosing this? Because one reason is that it is in plane, its motion is confined to a plane. Why polar coordinates? Why not xy? Why not Cartesian coordinates? Why are we choosing polar coordinates only? Because it has a symmetry which works well along the central direction, along this radius vector. So we are going to work in r and theta and not in x and y. Okay, we will not go for Cartesian coordinates, but we will choose plane polar coordinates. ठीक हो गया जी? ओके, तो अब हमें क्या करना है? आर और थीटा यूज करना है. इसकी सारे की कंप्लीट डिस्कशन आर एंड थीटा आर थोरली डिस्कस्ड इन द प्रीवियस लेक्चर्स. आप लेक्चर 1 देख सकते हो, लेक्चर 2 भी देख सकते हो, उसमें स्फेरिकल पोलर कोऑर्डिनेट्स और प्लेन पोलर कोऑर्डिनेट्स सब कुछ डिस्कस किया हुआ है, डिटेल में समझाया हुआ है। ठीक है, इसका लिंक मैं दे दूंगा, डिस्क्रिप्शन में भी दे दूंगा, और आपको अलग से भी चैनल पे भी है, आप वहाँ पे सारी वीडियोस देख सकते हो। ओके, तो अगर आपको इसमें दिक्कत है कुछ, तो आप जाके ये आराम से फिर से लेक्चर सुनो, पीछे पढ़ लिया आपने एक बार, फिर से सुनो, ध्यान से सुनो, और समझ के उसे फिर हम आगे बढ़ते हैं। तो वेलोसिटी, इसमें हमें दो चीजें चाहिए। आई विल यूज द डायरेक्ट रिलेशन हियर और रीराइट द रिलेशन फर्स्ट. First relation is of velocity. What is velocity in plane polar coordinates? It is given by r dot r cap plus r theta dot theta cap. This is the formula for velocity. Okay, this we have given its proof in the previous lecture. और acceleration क्या होगा? Acceleration होता है r double dot minus r theta dot square r cap plus 2r dot theta dot plus r theta double dot theta cap. Okay, this is the formula for acceleration. This is the formula for acceleration. Now what will we do? We will use these two relations. That's why I have covered them first. लिख दिया मैंने पहले, दिस इज लेट्स से इक्वेशन 1, दिस इज लेट्स से इक्वेशन 2. वी विल यूज दीज टू रिलेशंस इन द नेक्स्ट आर्टिकल. ओके, तो अब हमारा टारगेट क्या था? कमिंग बैक टू दैट थिंग, फर्स्टली वी हैव स्टडीड द सेंट्रल फोर्सेस and their properties, and then we have also seen that which type of coordinate system we are going to use and what are the velocity and acceleration values in that. Okay, based on all these things, now we will study motion of an object under the effect of a central force. ठीक है, central force लगाते हैं. तो क्या करेंगे? Let's take a heavier body M on the origin of the system, at the origin, and a small body M, and let's take its position vector in this way. This is a small body M. Small m means represents lighter body. Lighter body. Okay. And what is capital M? Capital M represents heavier body. So it's a two-body system. It's a two-body system. Both the bodies attract each other with the gravitational pull. Okay. So capital M applies a force on small m in this direction and attract it towards its center. Similarly, small m attracts the capital M towards its center. किसका इफेक्ट ज्यादा होगा, किसका नहीं, वो आपको मालूम है. But how to solve this problem? We have already discussed this thing, that such kind of two body problems, जो इसमें two body problem है ना, ये such kind of problems are reduced to a equivalent one body problem. ठीक है, so this is we have done in the previous class, earlier class, और ये हमने कर लिया. तो हम टू बॉडी प्रॉब्लम को वन बॉडी प्रॉब्लम में रिड्यूस करते हैं. कैसे करते हैं? यूजिंग द कॉन्सेप्ट ऑफ रिड्यूस्ड मास. यूजिंग द कॉन्सेप्ट ऑफ रिड्यूस्ड मास, which is defined as 1 by mu is equal to 1 by m1 mass of first body plus mass of second body. Here it can be written as heavy body m1 mass plus small body lighter body m2 mass is equal to small m, m1 is equal to capital M. Now since m is much greater than m, ठीक है, तो हम क्या कर सकते हैं? We can easily ignore this or neglect this term. Okay, this is neglected. So what we get? We get mu is approximately equal to small m. ये हमने पहले भी पढ़ा है. That reduced mass becomes equal to a lighter body. So what will we do? We will not study these two bodies. Okay, what we'll do, we will see the motion of lighter body around the heavier body, just like the sun earth system. Mass of sun is 10 raised to the power 6 times than that of the mass of earth. तो वो heavier body है, center of mass उसकी तरफ shift हो गया है, reduced mass इसके equal हो गया है अर्थ के मास के, और वो क्या परसेप्शन देता है हमें पता लगता है that earth is revolving around the sun. Okay, so this is done in this way. Okay, so similarly here we will take the reduced mass equal to mass of the lighter body, and then we will study the motion of lighter body under the gravitational pull of heavier body. This is our task. Okay, कितना होगा, कैसे होगा, वो फोर्स सेम ही है, फोर्स तो आपको पता ही है, क्या लगेगा Gm1m2 by r square, Gm1m2 by r square. डायरेक्शन देखनी है, और डायरेक्शन ये मैं एक बार वेक्टर हटा देता हूँ यहाँ से. We will rewrite it and then we will see the directions and all. Okay, so this is done. This is the formula for f. Now we need to do it vectorially and try to understand. We will try to understand how does this work, what happens in this. Okay, so let's see. अगर हमने केस क्या लिया है, हमने केस लिया है एक मास, एक ये रीजन एक्स एक्सिस वाई एक्सिस हो गए, ये मास कैपिटल एम हो गया, यहाँ से स्मॉल एम पोजीशन वेक्टर चला गया in this direction. This is the position vector of r vector, position vector of lighter body with respect to heavier body with respect to origin. Okay, ठीक हो गया, चलो आगे देखते हैं. This is the coordinates are r and theta, we know that. Okay, what is the relation for force? This is given by mass into acceleration. Mass is replaced by mu, reduced mass, we need to take the reduced mass of the system, and d square r by dt square, or we can say mu r double dot. This is more general notation in today's scenario. Okay, in this book, in this chapter, in this topic, mu r double dot. This is given by, yes, this is given by G capital M mass of heavier body, small m mass of lighter body, divided by r square in the direction of r. Okay, now you need to take care of this. Take a look on this and tell me whether it is right or not. Think about it for the next 30 seconds, and you need to tell them, you need to cross check your answer whether it is true or not. Think about it. If there is any mistake, you can tell me that. You can message me that. Okay, in the comment box, chat box. Yes. So you have 20 seconds are left. Ten seconds. If there is any mistake, rest of the work is straightforward. Okay, so now you can cross check your answer. I am writing it down. There is a mistake of a negative sign. Why is it so? Because the force is applied by capital M, which is trying to pull the smaller, lighter body towards its center, and we have taken the position vector r in this direction. So this is the way we need to take the negative sign here. Okay, although we can ignore it later on, but technically it should be there. Okay, अब क्या करना है? अब simple है काम. Now we need to put the value of acceleration, what we have earlier studied. Okay, ये देखो यहाँ पे हमने ले लिया था ये. This is the formula for acceleration. We need to put it on that, in that formula. Okay, कितनी वैल्यू थी इसकी? इसकी वैल्यू थी r डबल डॉट माइनस r थीटा डॉट स्क्वायर r कैप प्लस r 2r dot theta dot plus r theta double dot theta cap. Okay, this was the value. This is equal to this thing on the right hand side, minus g m upon r square r cap. Okay, so this is what we get. Now what we can do, we will put this acceleration, okay, this acceleration here, so we need to multiply it with mu as well. So ये मैं फिर से लिख दूंगा. Okay, so we will multiply this term with mu. We will get mu r double dot minus mu r theta dot square. I think we need not to put mu separately, and we can write it in this way. It's better to write it in this way. Plus 2 mu r dot theta dot, now I am multiplying it, plus r theta double dot mu भी आएगा, theta cap, this is equal to only one factor minus g m by r square r cap. Now what is the next step? We need to compare the two sides. Here r cap on one side will be equal to coefficient of r cap on another side, and coefficient of theta cap on one side must be equal to coefficient of theta cap on another side, which is 0. So this is our equation. Mu r double dot minus r theta dot square is equal to gmm by r square. It can be simply written as force Fr r cap. Okay, generally written in this way. Okay, so this is our equation. Mu r double dot minus r theta dot square is equal to Fr. R cap मैंने लिख दिया यहाँ, तो मैं r cap नहीं लिखता. ठीक, और आप एक चीज को एक तरफ यहाँ रख लो. म्यू आर डबल डॉट, व्हाट इज इट्स वैल्यू, इज इक्वल टू, नेगेटिव टर्म को उधर ले जाएंगे, म्यू आर थीटा डॉट स्क्वायर प्लस एफ आर. दिस इज अवर इक्वेशन ऑफ मोशन. ठीक हो गया. दूसरी इक्वेशन तो स्ट्रेट फॉरवर्ड ही है, उसमें तो कुछ है ही नहीं करने वाला. व्हाट विल यू डू? यू विल जस्ट पुट इट इक्वल टू 0. 2 म्यू आर डॉट थीटा डॉट प्लस म्यू आर थीटा डबल डॉट, दिस इज इक्वल टू 0. म्यू इज कॉमन, इट कैन बी टेकन आउट, बट एनीवेज even if we don't take it out, it is good because we will put it in some other form. Okay, what we will do, we will multiply this, all of these terms with r. Multiplying with r on both the sides, this will be 0. 0 multiplied with anything is 0. What will we get? We will get 2r dot theta dot and mu are constant. Okay, plus mu r square is a constant and we get theta double dot here. So if you see it carefully, what will you see? What you can observe, I am rewriting this expression. It is equal to mu 2r dot theta dot plus mu r square theta double dot. This is equal to 0. But carefully, by seeing this expression carefully, what we can write? We can write this mu into this term is derivative of r square. Derivative of with respect to t of r square. keeping theta dot same plus keeping mu r square same, this term is derivative of theta dot. Theta double dot is derivative of theta dot. So this is actually, we are using a product rule here, where we are putting one term derivative of first term second constant and derivative of second term first constant. So this gives you derivative of जो भी टर्म है, म्यू कांस्टेंट है, आर स्क्वायर का डेरिवेटिव ले रहे हो, थीटा डॉट का डेरिवेटिव ले रहे हो, सो कांस्टेंट ऑफ दिस, डेरिवेटिव ऑफ दिस, and if this is the derivative equal to 0, this is given by mu r square theta dot. It's a constant, okay, and it is actually angular momentum L. The formula for angular momentum L is equal to mu r square theta dot. L is equal to mu r square theta dot, and it is a conserved quantity in case of central forces. We have started by defining their properties, by defining the properties of central forces, और वो ही आ गया, सिंपल था, प्रूफ हो गया. तो कंजर्वेशन ऑफ एंगुलर मोमेंटम हो गया हमारे पास, एंगुलर मोमेंटम की वैल्यू भी निकाल ली हमने और उसका कंजर्वेशन भी हो गया. ठीक है, नेक्स्ट क्वांटिटी देखते हैं. नेक्स्ट व्हाट वी नीड टू डू, we need to calculate the value of energy. We need to calculate the value of energy. Okay, energy में क्या होगा, सिंपल है, energy is given by kinetic energy, total energy is given by kinetic energy plus potential energy. लिखते हैं हम बहुत बार, kinetic energy कितनी होगी, half mv square. Here mass is reduced mass is replaced by reduced mass. So it is v square, mu v square plus potential energy जो भी होगी, that is let's say u. U is general notation for potential energy, हमने पहले भी लिखी थी. ठीक है, अब इसमें v को आप पुट कर दोगे, v को वो पुट करोगे जो हमने शुरू में फॉर्मूला लिखा था, r डॉट प्लस r, ये v वेक्टर की वैल्यू है, r डॉट r कैप प्लस r थीटा डॉट थीटा कैप. v वेक्टर का मैग्नीट्यूड कैसे आ जाएगा, by taking the squaring and adding under root of, by taking the under root of their squares, the sum of their squares. ठीक है, अब आप पुट कर दो ये वाली वैल्यू, हाफ म्यू v स्क्वायर मतलब r डॉट स्क्वायर प्लस r स्क्वायर थीटा डॉट स्क्वायर, दिस इज योर v, प्लस u is as such, keeping it as such. So this gives you half of mu r dot square plus half of mu r square theta dot square plus u. Now here one more interesting expression can be substituted. Theta dot is L upon mu r square. From the previous expression we have written it L is equal to mu r square theta dot in this form. We are substituting theta dot from this expression and putting it equal to L upon mu r square. Okay, so this is what we have, what we'll put here. So what will be the total energy, will be equal to half mu r dot square. First term is remains the same, second term is half mu r square, theta dot square is L square divided by mu r square का square, that is mu square r4. ठीक है, और प्लस u, इसमें से mu r square कट जाएगा, कट के कितना आ जाएगा, टोटल एनर्जी कितनी आ जाएगी, हाफ ऑफ mu r डॉट स्क्वायर प्लस L स्क्वायर अपॉन 2 mu r square plus u. ठीक है, now see it carefully. This is called kinetic energy term, total energy में this is called kinetic energy term. This is due to rotational motion, it is called centrifugal potential energy. Okay, and this is the gravitational potential energy, and total this is called, sum of these two terms is called effective potential energy. ठीक हो गया? Okay, so these are the terms. What we get? We get the value of total energy and values of kinetic energy and centrifugal potential energy and gravitational potential energy separately. ठीक हो गया? एक और एक्सप्रेशन कर लेते हैं इसमें जल्दी से. क्या होगा नेक्स्ट चीज? वी नीड टू चेक वेदर एनर्जी इज कंजर्व्ड और नॉट. कंजर्वेशन ऑफ एनर्जी. तो हम कैसे कर सकते हैं इसे? इसे करने का क्या तरीका है? यू जस्ट टेक डेरिवेटिव. ओके, विद रिस्पेक्ट टू टाइम. डेरिवेटिव ऑफ हाफ म्यू आर डॉट स्क्वायर प्लस एल स्क्वायर अपॉन 2 म्यू आर स्क्वायर प्लस u equal to, this must be equal to, this will come out to be equal to 0. If this comes out to be equal to 0, then it means the term inside this bracket is constant. If it comes out to be 0, and finally we will get it turns out to be 0. Okay, how it will happen? Let me give you a glimpse of that. How it will happen? What is the derivative of first term? What is the derivative of first term? Derivative of half mu r dot square is given by mu by 2 into 2r dot into dr dot by dt. 2 से 2 कट जाएगा और कितना आ जाएगा? mu r dot and derivative of r dot is r double dot. This is our first expression. Okay, now see the second one. Second is L square by 2 mu r square. What we will do for this? We will take its derivative with respect to r, L square upon 2 mu r square, and derivative of r with respect to t. This can be easily written as r dot. dr by dt is r dot. अंदर क्या बचेगा? इसका डेरिवेटिव में क्या आएगा? -2r by r cube, -2r by r cube. Okay, so L square upon 2 mu कांस्टेंट है और 1 by r square का डेरिवेटिव होता है -2 by r cube. -2 से -2 प्लस 2 काट दो और ये हो जाएगा माइनस r डॉट L स्क्वायर अपॉन म्यू r क्यूब. ये कुछ ऐसा हो जाएगा. ठीक, और u का डेरिवेटिव भी सेम हम ऐसे ही करेंगे. हम लिख लेंगे r डॉट और डेरिवेटिव ऑफ u. ओके, ठीक हो गया. डेरिवेटिव ऑफ u विद रिस्पेक्ट टू r इज fr. हमें पता है fr is given by minus of curly u by curly r. From the definition we know this thing. The central forces can be written as the negative gradient of the potential energy, gravitational potential energy. So by putting these values we will get what we will get. लिख देता हूं मैं. We will get mu r dot r double dot minus r dot L square by mu r cube minus r dot fr equal to, हमें निकालना है, जो भी हो हमें निकालना है. ओके, fr को मैंने क्या किया? ये करली u by करली r को माइनस ऑफ fr पुट किया, तो ये हो गया. ओके, नाउ r dot can be taken out. What we are left out with? r dot मैंने बाहर निकाल लिया और बाकी क्या बचा उसे मैं लिख रहा हूं. म्यू आर डबल डॉट माइनस कितना है, आर डॉट बाहर, एल स्क्वायर बाय म्यू आर क्यूब विच इज एक्चुअली ऑफ डेरिवेटिव ऑफ समथिंग, वो भी देख लेंगे, ठीक है। और कितना होगा, एल स्क्वायर अपॉन म्यू आर क्यूब और माइनस ये आर डॉट बाहर निकल गया, एफ आर अलग से आ गया। ओके, नाउ दिस वाज गिवन बाय द फर्स्ट एक्सप्रेशन। फर्स्ट एक्सप्रेशन जो इक्वेशन ऑफ मोशन थी, इफ यू विल सी दैट, I'll go back to that equation. Okay, look here. This is what mu r dot is mu r theta dot square plus f r. Okay, I will rewrite this equation. What was it equal to? This was equal to mu r theta dot square plus f r. ठीक है, what is theta dot? Since we have L is equal to mu r square theta dot, so theta dot becomes L by mu r square. Okay, and after substituting it here, what we will get? We will get mu r theta dot square is equal to mu r into L square divided by mu square r power 4, which will be cancelled out with 1 power with this, 1 power with this, so we got this term. Okay, so mu r dot double dot is equal to L square by mu r cube plus f. And since this is equal to this, by putting this value in this equation, for these two terms are absolutely same as that of this, so this will give us a value 0. And since d total energy upon dt gives you a 0, we can say energy is conserved in the system. तो ये हमने सीखा, इससे कंजर्वेशन जो है, हमने सेंट्रल फोर्स के अंदर एक मोशन देखा बॉडी का, और उसमें देखा कि इक्वेशन कैसी आती है, उसमें एनर्जी कांस्टेंट रहती है, कितनी रहती है और कंजर्व रहती है या नहीं। सिमिलरली एंगुलर मोमेंटम कितना रहता है और कंजर्व रहता है कि नहीं। सो दिस वाज द एक्सप्रेशन और दिस वाज द आर्टिकल, कंप्लीट आर्टिकल. You need to understand it properly. It's very simple but very important article. Okay, चलो अब अगली क्लास में मिलते हैं हम. Till then पढ़ते रहो, आराम से काम करते रहो, और अगले लेक्चर के लिए बिल्कुल साथ में रहना. स्टे ट्यून टू आवर चैनल, और उसमें मैं आपको बाकी की वीडियोस भी भेजता रहूँगा. ये ऑनलाइन क्लास में ऐसे ही काम चलता है. ठीक है, ओके.